The Arsenal of Democracy. How an automobile company redefined warfare in 7 minutes. The telephone call on June 7, 1940, was brief, its 7-minute duration belying the tectonic shift it would trigger in the global balance of power. From Washington, D.C., William S. Knudsen, the newly anointed Commissioner of Industrial Production and a former president of General Motors, posed a question that bordered on the absurd to the industrial mind of Detroit. He was not asking about automobiles or consumer goods. He was asking about instruments of war. "Can Chrysler," he inquired, "build tanks?" On the other end of the line, K.T. Keller, the pragmatic chief executive of the Chrysler Corporation, responded with a characteristic lack of pretense. "I don't know," he admitted. "I've never seen one of these things." This moment of stark honesty, far from being a confession of incapability, was the first step in a revolutionary industrial undertaking. At that precise moment, the military reality was terrifyingly clear. The United States Army possessed a mere 66 medium tanks, a force so negligible it could have been annihilated in a single morning by the Nazi war machine. Across the Atlantic, Germany had deployed over 3,000 panzers, perfecting the doctrine of blitzkrieg to shatter Poland in 26 days and force France to capitulate in a mere 6 weeks. The mathematics of defeat were being scrawled across the European continent in fire and blood. Unbeknownst to either Knudsen or Keller, their concise conversation would catalyze the most profound and rapid industrial metamorphosis in the annals of military history. It would set in motion a chain of events that, within a scant 9 months, would see Chrysler accomplish what entrenched military arsenals had deemed unattainable. The tank, a 30-ton behemoth of steel that traditionally required months of painstaking labor by master craftsmen, would be reimagined as a product of the assembly line, rolling forth with the same relentless rhythm as a family sedan. At its peak, a new tank would emerge from the factory every 55 minutes. This unprecedented process would systematically dismantle every entrenched assumption about military manufacturing, proving conclusively that American industrial genius could weaponize the very concept of mass production. The challenge began with a problem of foundational proportions. In the summer of 1940, the United States ranked a humiliating 19th in global military power, trailing even Portugal. Its army was a force more reminiscent of 1918 than 1940, with more horses in its inventory than tanks. The Army Ordnance Department, the entity responsible for the development and procurement of weaponry, operated under production methodologies that had remained fundamentally unchanged since the First World War. Tanks were assembled by hand in government-owned arsenals like Rock Island, Illinois. Each vehicle was a unique creation, a metallic sculpture where components were hand-fitted and adjusted by skilled machinists and armorers. At maximum capacity, Rock Island could produce perhaps 3 medium tanks per month, with each unit requiring up to 12 weeks to progress from raw materials to a battlefield-ready machine. German panzer production, while more advanced, still relied on similar craft-based principles, albeit supercharged by years of clandestine rearmament. By 1940, German industry was delivering approximately 1,400 tanks annually across multiple specialized factories. Britain, though more mechanized than the US, managed only about 1,000 tanks per year. Every major military power shared a core dogma. Tanks were sophisticated, bespoke weapon systems that demanded the touch of master craftsmen, specialized facilities, and months of meticulous stationary assembly. Immediately after concluding the call with Knudsen, Keller summoned his most trusted lieutenants, B.E. Hutchinson, his sharp-minded chief engineer, and Frank W. Zeder, Chrysler's vice president of engineering. The trio convened in Keller's office within the hour, facing an impossible proposition. The U.S. Army needed 1,000 medium tanks. It needed them in less than 18 months, and it was asking Chrysler, a company with zero experience in armored vehicles, to simultaneously design the production methods, construct a factory, and deliver the finished goods. Hutchinson immediately cut to the heart of the logistical nightmare. What's the current production time for a tank? Zeder, having done his homework, delivered the grim statistics. Rock Island produced 3 M2A1 medium tanks monthly, taking 12 weeks per unit with skilled craftsmen hand-fitting every component. Hutchinson performed the quick, devastating calculation. At that rate, fulfilling the Army's order would require 277 years. Keller's response was definitive and would become the program's guiding philosophy. We don't build tanks the Army's way. We build them our way. If they want 1,000 tanks in 18 months, they need to accept automobile production methods, which means we need to see what we're building. Their pilgrimage to the Rock Island arsenal was an education in obsolescence. They observed workers painstakingly hand-fitting armor plates, adjusting track tension by eye and experience, and custom machining parts to account for wide tolerance variations. The M2A1 medium tank, a 19-ton vehicle armed with a 37mm gun, comprised roughly 8,000 individual parts, all manufactured to loose tolerances that necessitated skilled adjustment during assembly. No two tanks were truly identical. Keller recognized the fundamental impediment immediately. "This isn't manufacturing," he declared. "It's sculpture. Every part depends on the craftsman's skill. You can't scale this. You can't train new workers fast enough. And you certainly can't produce 1,000 tanks in 18 months. Returning to Detroit, the trio convened a secret tank committee, a dedicated working group tasked with solving this seemingly intractable problem. The committee included brilliant minds like Owen R. Skelton, Chrysler's chief production engineer, alongside specialists in tooling, metallurgy, and logistics. They commandeered a conference room at the Highland Park facility, working daily and often through the night. Their paradigm-shifting breakthrough came from inverting the core question. Instead of asking, "How can we build tanks faster using established methods?" they asked, "How can we build tanks as if they were automobiles?" Skelton articulated the revolutionary insight. An automobile is 2,000 pounds of steel, rubber, and glass assembled from 5,000 parts. We make 3,000 of them per day at Highland Park. A tank is 60,000 pounds of steel assembled from 8,000 parts. The only difference is scale and purpose. This reframing was transformative. If a tank was simply another complex mechanical assembly, then the core principles of automobile production, interchangeable parts, precision manufacturing, and a moving assembly line, could be applied. This required a complete reimagination of tank manufacturing from first principles. Every component would need to be redesigned for mass production, every assembly sequence re-engineered for a moving line, and every quality control checkpoint shifted from craftsman's intuition to measurable, objective specifications. The committee's analysis revealed that a staggering 60% of the production time at Rock Island was devoted solely to custom fitting and adjustment. Parts manufactured to military arsenal tolerances varied so widely that assembly became a constant exercise in adaptation. Hutchinson proposed the radical solution. We manufacture every component to automobile tolerances. Then they fit together without adjustment. To military engineers, this was heresy. Tank components endured stresses far beyond those experienced by automobile parts. Achieving such precision would demand new tooling, new supplier networks, and unprecedented quality control. Yet the potential payoff was astronomical. A process requiring 500 man-hours of assembly could potentially be slashed to 150 man-hours if components simply bolted together. Skelton pushed the concept further. If we're treating this like automobile production, he argued, we need an assembly line, not a series of workstations where craftsmen gather around a stationary tank. We need a moving line that brings the work to stationary workers, each performing a specific, repetitive operation. By November 1940, the committee had formalized the Chrysler method for tank production. It mandated precision-machined components, standardized and interchangeable armor plates, welded hulls using production jigs instead of rivets, and a final assembly on a moving line with specialized workstations. Keller's presentation of this method to the Army Ordnance Department was met with profound skepticism, bordering on hostility. Military engineers argued that automotive tolerances were insufficiently robust for combat, that moving assembly lines would compromise quality, and that welded armor was inferior to riveted construction. They dismissed the proposed production rate of 10 tanks per day as pure fantasy. Keller, however, possessed one irrefutable argument. "You need 1,000 tanks in 18 months. We can deliver them. Can anyone else?" The Ordnance Department had no answer. In late November 1940, Chrysler received an unprecedented contract. The Army would fund the construction of a purpose-built tank factory, and Chrysler would design, equip, and operate it. The contract included one crucial stipulation: the facility must be designed by Albert Kahn. Albert Kahn, a 71-year-old German Jewish immigrant, was the visionary architect who had literally shaped the face of American industry. Having never formally attended architecture school, he learned his trade as an apprentice. By 1940, his firm, Albert Kahn Associates, had designed nearly 1/5 of all architect-designed industrial factories in the United States, including Ford's revolutionary Highland Park and River Rouge complexes. Kahn's genius lay in treating factories not as mere buildings, but as machines for production. His designs maximized natural light, optimized material flow, and created vast, column-free spaces that allowed for flexible and efficient production layouts. He was a pioneer in using reinforced concrete, which enabled faster construction and larger open floors than traditional steel frames. When Keller presented Kahn with the requirements in early July 1940, they seemed mutually exclusive. The facility needed to be colossal, bomb-resistant, built in mere months, and convertible to civilian production after the war. Kahn accepted the challenge without hesitation, throwing his entire 600-person firm at the problem. The design for the Detroit Arsenal tank plant was a masterpiece of industrial logic. The main building would encompass 1.25 million square feet under a single roof, making it one of the largest industrial structures on Earth. Its design featured 3-foot-thick concrete walls in critical areas and a reinforced roof with steel trusses designed to deflect bomb blasts. Kahn's layout was the physical embodiment of the Chrysler method. A main assembly line would run a quarter-mile through the building's length. Feeder lines would deliver major components to the main line at precise intervals. Machine shops for drivetrain components occupied the northern sections, while welding bays for hulls and turrets filled the southern wings. The entire facility was designed for a linear material flow, with raw steel entering at the west end and finished tanks rolling out the east. One of Kahn's most ingenious innovations was a sunken assembly line, a trench approximately 4 feet deep. This allowed tanks to be carried along at a height where workers could easily access their undersides for suspension and drivetrain installation without the need for jacks or pits, saving hundreds of hours per vehicle. Groundbreaking occurred on September 9, 1940, on 113 acres of farmland in Warren Township, Michigan. The ensuing construction was a frenzy of coordinated activity, a race against time enabled by Kahn's use of reinforced concrete, which cured rapidly. By February 1941, the main building was structurally complete, but remained a hollow shell, lacking windows, heat, and finished interiors. Undeterred, Keller made a legendary decision. They would begin building tanks inside the unfinished factory. The result was a surreal scene of industrial determination. That winter, workers assembled the first tanks in frigid conditions, their breath visible in the air, warmed only by the improvised solution of a steam locomotive parked inside the building, its boiler providing makeshift heat. This was not careful planning. It was industrial will made manifest. Concurrently, the tank committee was solving a cascade of technical challenges. The M2A1's transmission, designed for hand assembly, was redesigned as a modular unit, slashing its assembly time from 40 hours to 4. The suspension was standardized, with complete bogies pre-assembled in 2 hours and bolted to the hull in 20 minutes. The most contentious issue was the hull. The Army insisted on riveted construction, the proven method. Chrysler advocated for all welded hulls, arguing they were stronger and faster to produce. The company systematically countered every objection, producing test welds that proved superior in ballistic tests, developing heat treatment processes to eliminate stress, and demonstrating that semi-skilled workers could produce perfect welds using production jigs after just 2 weeks of training. The engine dilemma required particularly creative problem-solving. The preferred Continental R975 radial aircraft engine was in critically short supply. Chrysler engineer Harry Wilson proposed an audacious alternative, combining 5 of Chrysler's standard inline 6-cylinder automobile engines into a single, monstrous power plant. The resulting A57 multibank engine was a Rube Goldberg-esque marvel of complexity, 30 cylinders arranged around a central gear case, producing 425 horsepower. The Army hated its complexity, but they could not argue with its practicality. It used existing tooling and components and could be put into immediate production by semi-skilled labor. On April 12, 1941, one day before Easter, the first Chrysler-built M3 medium tank was completed inside the still unfinished freezing factory. The M3 was an evolutionary design, already obsolescent, with its main 75mm gun mounted in a hull sponson. But it was historic, the first tank ever produced on an automobile-style assembly line. At its formal unveiling on April 24th, Keller rode in the tank as it emerged into the spring sunshine, demonstrating its capabilities to a crowd of skeptical military officials by crushing obstacles and firing its guns. What followed was a relentless ramp-up of production. By May, a tank was completed every other day. By June, it was 1 per day. By July, 2. The attack on Pearl Harbor on December 7, 1941, transformed the endeavor from an urgent project into a national imperative. The Army's requirements exploded. Chrysler responded by accelerating the pace further. The key to this scaling was the development of a vast supplier network, orchestrated by B.E. Hutchinson. He enlisted over 400 companies across 32 states, providing them with technical assistance and guaranteed contracts to produce everything from final drive housings to track pins. The workforce itself was a testament to this new industrial doctrine. From 0 employees with tank experience in June 1940, the Detroit Arsenal employed 5,800 workers by August 1941. Chrysler established internal training schools where new hires learned specific repetitive operations on practice fixtures before ever touching a real tank. The culture became intensely focused on metrics. Daily production totals were publicly posted, fostering competition between shifts. A team of production expediters constantly roamed the floor, identifying and eliminating bottlenecks in real time. The ultimate validation of the Chrysler method came in December 1942. In that single month, the Detroit Arsenal produced 896 M4 Sherman tanks, nearly 29 per day. This one facility was outproducing the entire German tank industry. This staggering output was the result of continuous, relentless optimization. The initial 500 man-hours required to build the first M3 had been slashed to just 150 man-hours for an M4 Sherman. The assembly line moved with metronomic precision, a new tank advancing to the next station every 55 minutes. By the war's end in August 1945, the Detroit Arsenal had produced 22,234 tanks, roughly 1/4 of all American tank production. The M4 Sherman, designed from the outset for mass production, became the workhorse of the Allied armies. While often outgunned by heavier German tanks like the Tiger and Panther, the Sherman's advantages were strategic, not just tactical. It was reliable, easy to repair, and above all, available in overwhelming numbers. The United States built approximately 88,000 to 90,000 tanks during the war. Germany managed only about 24,000. This numerical superiority, enabled by production methods pioneered at Detroit, was a decisive factor in the Allied victory. The legacy of the Detroit arsenal is profound. It proved that private industry could solve military production problems with far greater efficiency than government arsenals. It validated the arsenal of democracy concept, demonstrating that American industrial capacity, when mobilized, was a war-winning weapon in itself. The philosophical shift from craft-based to industry-based military manufacturing, triggered by a 7-minute phone call and brought to life by the brilliance of engineers and industrialists, fundamentally reshaped modern warfare and cemented the relationship between industry and the military that defines the American defense landscape to this day. It was a triumph not of superior weaponry, but of superior production, a testament to the power of asking not "can it be done?" but "how will we do it?"